This is a map of the continents of the world. And if you look at it, it looks like you could take all the continents and squeeze them all together and they'd fit. It looks like South America would squeeze into Africa, and the bulge in Africa there would squeeze into the Caribbean, and Europe would fit against the United States, and Greenland could come down against Labrador down to Newfoundland. It looks like it would all fit together. One of the first guys to notice this, to document noticing this, was a guy named Alfred Wegener. Alfred Wegener came up with a theory that said that this stuff all fit together. All the continents were at one time combined, probably when they were formed. And he called this one great big continent, he called it Pangea. Pan meaning all encompassing, and Gea from the Greek, I would guess, meaning Mother Earth. Now, he published his theory, and people pretty much laughed at him. The rest of the scientific community at the time thought, it's totally impossible. There's no way that it's possible. The energies involved to move continents are absolutely incomprehensible. Now you gotta remember, this is pre-nuclear age. But still he published, and he got the idea in people's minds that maybe they did fit together at one time. I watched a documentary in 2005 when it first came out. The Vice President of the United States, Al Gore, he did a documentary called An Inconvenient Truth. And he talked about being in grade school. And when he was in grade school in the 1950s, I would guess, early 60s, excuse me, he said to his teacher, you know, it looks like Africa and South America were once joined. And it looks like you can push all the continents together and they fit together. And his teacher said to him, are you dumb? Like, how is that possible? There's no way that could happen. There's no, it's scientifically impossible. You know, you're not a very intelligent boy. You should look at your career choices because you're probably not going to amount to much. Well, I guess he thought outside the box because he ended up being the VP of the United States. You know, that kind of says something. I think he accomplished a bit. He's a Nobel Prize winner, for the love of God. Back to Alfred Wegener. When Alfred Wegener made his claim, he couldn't just say, you know, I think this. Because he would need evidence. He was a scientist, so he would need evidence to back up his claims. So he went looking for evidence, and he found lots of evidence to support his claim that the continents were at one time joined together. An example of some of the evidence is he found biologic evidence and geologic evidence, and he found climatic evidence. Wegener was a climatologist, so we'll go with climate first. The first evidence that he uncovered that would support his claim, we have in Glace Bay. If you go to the Glace Bay Miners Museum, before you walk in the museum, you stop, look around, look at the trees, look at the biome. You got two types of trees in Cape Breton. You got conifers like spruce and fir, Douglas fir, and pine, and you have deciduous trees. You have trees like sugar maples, like birch trees, like popple trees, aspen. That's native to our environment. It's called the Acadian forest. Yet, if you go inside the museum and you look around at the fossilized remains, you will see fossils that don't look like they came from here. You will see palm trees, and you will see species of fern that can only grow in subtropical or tropical environments. Well, look at the winter we just had. Cape Breton is not a tropical environment. I've never ever seen coconuts growing on trees here. It's not a tropical environment. So how is it possible that just underneath our feet, underneath our soil, there are fossilized remains of tropical plants? For that to happen, Cape Breton at one time would have had to been in a tropical area, because currently it's not. So how is it possible that Cape Breton moved? Think of the energy involved. Like, if I was to go up to Glace Bay High School and work out for a month beforehand and put my hands against the high school and really push as hard as I can, I'm not going to move that school. I'm not going to budge it. Because I just don't have the energy. There's no tractor I could buy to push a school Now that's only a school, it's very, very small in comparison to a continent. So scientists at the time believed that they just didn't have, there's no powerful force, there's no force with enough power to move a continent that they were aware of at the time, because they were in the early 1900s, they weren't really up to speed on plate tectonics, which we'll get to in the next lesson. So Wagener's theory of continental drift, he supported it with evidences. The first evidence we talked about was climatology. Fossilized remains in the ground in Cape Breton don't match the current environment. Biology. Early explorers into Canada were looking for, the French when they came to Canada and North America, they were looking for beaver fur. And they found that the further west and the further north you went, the thicker the furs. So that's where they went. And they came upon a fish. And the fish, they didn't know what to call it, because the fish was almost an exact biological replica of a fish from France. So they looked at the fish and they called it no name. They called it incanu. And the word, for those of you who take French, the word incanu en France means no name. So the fish that's called the no name fish is very similar to a fish in France. So how's that possible? You guys would have all taken Science 10. You would have did in Science 10, I would hope anyway, you would have done osmotic processes. So you would have covered hypertension and hypertonic, and hypotonic. So you would know that a fish in France, two fish, a boy and a girl fish, couldn't say, let's move and jump in the Atlantic Ocean and swim across the Atlantic Ocean and find a nice river in Canada. Physiologically, they could not do that. Their cells couldn't handle the transformation to go from freshwater to saltwater. It is physiologically impossible. So how did they get to North America? There's no other explanation other than North America at one time must have been joined to the European continent. Other evidence that Alfred Wegener offered is geologic. Now, geologists noticed rocks in Newfoundland and rocks in Scotland were formed at the same time, in the same place, from the same magma stream. We know this because we can carbon date them. So if you carbon date them, you get a pretty close age, a pretty good age, you know when they were formed. So you can age the rocks in Scotland, you can age the rocks in Newfoundland, formed at the same time. If you analyze the structure of the rock, you see that they had the same substructure. They're composed of the exact same thing. Now, it is possible for rocks to be formed at about the same time in different spots that have pretty much the same thing. So there's one kicker that really, really can tell you if rocks were formed at the same time. And that's a field, and it's called paleomagnetic polarization. When the rocks are formed, the ferrite, the magnetic components of the rock align with the magnetic fields of the Earth. So we know from paleomagnetic polarization and from carbon dating that rocks in Newfoundland and rocks in Scotland were formed at the same time in the same place. Well, how's it possible? Newfoundland and Scotland are thousands of miles apart. So how's it possible that they drifted away? That was Wegener's theory. That's the theory of continental drift. He couldn't explain it. He didn't know. All he knew was that the continents were once joined. All it appeared to him is the continents were once joined and they spread apart. He couldn't explain how it happened. He couldn't tell you what the forces involved were. All he knew was that he thought it was correct. So think about that.